Right guys, what I thought I'd go through in this video is the different stores of energy that you need to know about for your GCSE physics. So there are 7 different stores of energy that you need to be aware of, okay? And they are magnetic, internal energy, which you may also hear called thermal energy, chemical energy, kinetic energy, electrostatic energy, gravitational energy, and nuclear energy. So what I want to do is just spend kind of, 30 seconds, a minute, talking about each one, some examples where you might find them, and some common transfers between different stores of energy. I'll be doing a separate little video about some transfers, so I won't spend too long on that, mainly just kind of name checking the 7 different stores. So the first one, magnetic, this is the energy stored by 2 like poles, so north-north or south-south, when they're brought close to one another. If you bring 2 south poles close to one another, they really want to push themselves apart, okay? They store energy, which is released when you let go, and they force each other apart. Okay, and you get the opposite with 2 opposite poles. So if you get a north pole and a south pole and you bring them far away from each other, they really want to be brought back together. Okay, it's a bit like a spring, yeah? Where you stretch a spring. They really want to go back together. That's the magnetic store of energy. You've then got internal energy. So internal energy is made up of 2 parts, which we'll go into more detail later. You've got the heat or the thermal side of it, and you've got the potential energy side of it. We'll just concentrate on the thermal for now. So all objects have got a certain amount of internal energy if they're above absolute 0, which is minus 273 degrees, which everything is, so we don't need to worry about that. Basically, everything's got some thermal internal energy. An ice cube's got thermal internal energy, hot tea's got thermal internal energy. And it's really, it's just a type of kinetic energy. It's where the particles in the substance are moving around. Chemical energy, one that often catches students out. Chemical energy is energy that is stored within the bonds of different compounds or molecules. Okay. Chemical energy is found in food. It's why we eat it, because when we eat the food, we can turn that chemical energy into kinetic energy. We can turn it into thermal energy because we're warm-blooded. We've also got batteries. Batteries store chemical energy. They don't store electrical energy. They're not electric until you put them in a circuit. Just a battery in a battery pack that you buy from Tesco's or whatever. That's storing chemical energy. You then got kinetic energy, one that I'm sure we're familiar with. This is movement energy, okay? It's found in any object which is moving, okay? So a meteor or a meteorite has kinetic energy. A runner has got kinetic energy. Electrostatic energy is caused by the attraction or repulsion of 2 different charges. It's quite similar to magnetic, but instead of magnetic poles, north and south, you've got electric charges, positive and negative. This is found in things like thunderclouds. Okay, it's what causes the lightning to go from the cloud to the floor. And you may have seen, or you may not have seen, the Van de Graaff generator. Okay, it's that metal orb that gives off sparks. That's also a store of electrostatic energy. You've then got another very common one, which is gravitational potential energy. This is stored by objects that are raised up from the ground, okay, raised up in a gravitational field. So anything which is on a hill or on a shelf has got gravitational potential energy. Kites, I've run out of ideas. Kites have got gravitational potential energy. So there's a very, obvious transfer here. So as a meteorite falls, it's going down, yeah, it's going towards the Earth. So as the meteorite falls, it's losing gravitational potential energy, but gaining kinetic energy as it speeds up, okay? And finally, you've got nuclear energy. This is energy that's stored within the nucleus of atoms. It's different from chemical. Chemical energy is stored in the bonds between atoms, while nuclear energy is stored within the atom itself. It's actually much harder to get hold of. So you've got nuclear power stations, they take advantage of nuclear energy, and nuclear weapons, they take advantage or disadvantage, I suppose, of nuclear energy. Now, one thing to be very, very aware of, which I'm sure you've heard lots of times before, is you cannot create or destroy energy. When the ball rolls down the hill, it's lost gravitational potential energy, but it would have gained one of the others. As it's rolling down the hill, it's gaining kinetic energy, it's speeding up. Once it's at the bottom of the hill and it starts slowing down, well, that looks like you might have destroyed energy because you've no longer got any gravitational potential energy and it's slowing down, so it's losing kinetic, okay? But the energy is going to thermal, okay? If you were to measure the temperature of the object or of the ground as it fell, as the object rubs against the ground, okay, its heat will increase, probably only by a tiny amount, but it will increase, okay? So, I hope this has been useful. I'll go into a bit more detail about transfers in another short video. Okay, bye.